I was asking you to compute. So take a look at the two group works that I've just given back to you. I was actually asking you to evaluate not just the probability of a type 1 error, that's actually easier, but we also talked about type 2 errors. And if you remember, first of all, every test that gets derived is always really some statement like reject the null if something happens. So your first job in that group will be, okay, go find what this number is, this T alpha, so that this test has a certain probability of a type 1 error. Log that down, get your test, then you can calculate the type 2 error. Because the type 2 error is basically based off the same decision rule that you've made, but with a new level of mu that I tell you now for what the truth actually is. So let's immediately have you do another group work to give you more practice on these kinds of things. This question here, I give you the test and ask you to find the probability of type 1 error, right? And you don't have to do number 5. I will show you some R code for that, then you can do number 5. Right? Just do 1 to 4. That's all you say, because I haven't told you what to do. And we have done for 4, yeah. So now just try to do 1. Consider.
Oh.
Yeah.
So that was the part.
Yeah.
We're just going. I'm just going.
Oh, that's no good. That's right. So you don't have to know where these rules come from. I'm giving you two rules and just asking you to find reasons. Yeah. Right. Are you-
Want to go for it.
Okay. So just what's the definition of a type one error? You make a type one error. You decide to reject the model.
Check it all and then I'll
Right. So when do you reject the now when it's happened. That's right. So actually, you think the most you feel right. That's right. And what's the truth here? So I want everything happens. So decide to reject the knowledge. The truth is you is actually the knowledge. So you really is. You can. So these things are deceptively. They seem easy, but they're quite confusing. So let me say this here. Type 2 errors happen as a race when you decide to not reject the law, which would happen when that is correct. But the truth is, the mean is actually something. The opposite is, you make a type 1 error, I do decide to reject it. But the true value of what I can. So,
I guess I understand.
this is why.
I guess I'm confused how we get to the problem. I think I understand that it's the rejection, but because we don't have observed something.
Oh, yeah, that's a very good question. This question is the opposite because yes, that's right. This is a question. First of all, and this question asking you to develop any rule. That's what you do. You actually do this question. You don't need to know what's the rule. You're just asking a question. I want to reject it now where this happens. So what should my do? This question bypasses that by giving you the rule. And I'm just asking you to go in reverse and say, with this kind of rule, what is the problem? Can you reconcile it? This one is doing us where that comes from. This one is basically trying to develop where you want the probability for rejecting the null or true. And I'll let you think about it. I'll come back. Yes. Okay. Sorry. Yeah. So the seven but what is the true value of something is right? That's why type 2 errors are always true.
That's
You define as the number is R in multiple. Plot with different values. So you can look at happiness.
not the one.
You're not concerned by where the rule comes from. You don't need to. I'm giving you a rule and asking you. They're basically going to look at which rule is better. You find that there is no one that is better. One rule that is worse for type 1 error is better for the type 2 error. Basically, come up with. So this you can add a few this. So this is the probability of that standardized thing. Uh, Good to you. Standardized. Oh, no. 5. See, 5 is on this, right? When you standardize, you do the same thing. That's right. Actually, what you don't standardize 7. Yeah, standardize with 300. When you standardize, yeah, that's what the says. Sigma square. Oh, sorry. This was yeah. Square root of square. So wait, square root of yeah. And this is some. And I think when you send the methods, basically. So you started by saying this. You have something like this. So when you standardize, what you do is you subtract and you divide, and you do this consistently on both sides. Like, do you see what I'm trying to do? Then this will turn into z. So here you subtract the true mean and you divide by the standard deviation of this guy. Like that. So you don't jump and say, oh, this is y bar minus 5. You're not standardizing by subtracting y bar. You are standardizing by subtracting the true mean to both sides. That's what you're doing. Am I making sense? Yeah, that takes care of it more. But if you do the same to the one, good. That's right. And then see what you did to y bar to the 5. Right? Yes, because 5 is a 10.
I think that was wrong. Yeah.
Is it easy? Yes. Which we are.
Yeah.
Okay. So first of all, are we finding that you have different type 1 error probabilities for question 1 and question 3? Which one was lower?
Right.
Which one was lower than that? I think one was very bad, like half or something like that. That's very, very, very bad. But we will find that you plot on our that when a rule is not so good when it comes to a type 1 error, it's better for type 2. It's very hard to find one that wins for both. All right. So what code do you need to draw things like that? So let me get so I have some code which I will share with you now. Wrong page. The code that we want to use is actually our code for check. So here's something you can try. I don't think I need to actually send you the code. I think you can look at it and figure it out. Right? Just give me 1 minute to see if I can zoom in on this page a bit. Okay, so look at the code. Do you see? Okay, this is for a different problem, but I'm sure you can adapt it. Okay, first of all, you can make a sequence of mu values or mu zero if you like. The truth is mu zero. So I've done SEQ 70 to 72, 0.00. What does that do? That gives you a sequence of numbers starting from 70 all the way to 72, incremented by 0.001. I think that's quite easy to understand. So set that up in this context. I believe you want to start your view from what the power functions for this. Oh, for mu's between 5 and 6. So can you modify this code to for the true values of mu to be between 5 and 6? That's what we want. And then you see, look at what I've defined. Type 2 error problem is P norm. Okay, what is that? P norm is the probability of seeing that thing. Now, P norm by default is a less than probability. So in other words, P norm, and you don't, if you don't specify the mean and the variance, the default is 0, 1. P norm B tells you the probability of a standard normal less than or equal to 0. So with that in mind, can you modify this code, plot the power function? And you can have a look. Do it for rule 1 and also rule 2. Right? This is where R really comes into its own because it helps do a lot of tedious calculations. What the whole purpose of group work 22 was to show you type 1 error probabilities can always be computed numerically. Type 2 will give you a function of the parameter because it depends on what the truth is. That's the point I want to get across to the class. You all are getting the what's the rule, what is the rejection rule, and how does it change when you accept the noun. That's really good. This class has got that down, which is good. The only thing you need to realize is to compute type 2 error probabilities, you need to know the truth. And we are now telling you, set up the truth to be everything between 5 and 6, and you can increment it the same way I did at 0.001. This will just control how nice your graph looks. So try plotting it, and then I'll take a look as I walk around the class and see whether you can see other two. Now, if you want two rules and you want to plot them together, well, just do that line, right? You mu 0 is fixed. You have the same values of mu. But then you define two power functions, power 1 and power 2. And then just use a different color. The default is black, so color equals to 0. If you ran those two lines, you will get two curves on the same set of axes. So you can give that a try, all right? Is it working? I'm getting something. Any artworks that I just modify it to be in context of a group book. Okay, so you can send me a screenshot of your graph. You don't have to share anything else with me. You can just screenshot your graph. Um, if you put them both on the same axis, it's a little easier. You have separate graphs, that's also fine. Okay, the other group work, today we are going to do quite a bit of group work incrementally because I find it's quite good to teach this today, which is will be slightly more complicated. This one, sigma is not Yes. Oh, I think we are okay. Okay, we are not considering hypothetical. So I think we put one other thing.
Oh, okay, we only know.
Yeah.
Okay, I was confused by
There's no
two
two.
different decisions.
Yes, yes, there are two rules, but we are plotting the power curves for both rules. That's right. Type one error is not range is just one. It's just one, right? Because type one error probability is relative to the downstream and how it's just supposed to move. Because the complexity of the type two error is positive. When that is not true, yeah, then what is true? And so you have the possibility of the range of use true. That's why you solve for a different type of error. If you don't solve for one error,
So we'll just be.
they're both, it will be type 2 error from, if you want type 2 error from 1 to from 2, from 1 to this is for one particular.
Good. On the screen for.
Yes.
Point two six.
How do you get it? One, okay. Right, good. That's right. This part is actually nothing but
Yeah.
the only thing is the language of calculate. Yeah, so you basically want to say reject the now when something very similar to starting from when x bar and smaller than something. So it's basically what should that number be? Right, good. X bar minus yes. Yes. It exceeds. Just work it out until you get something. Right? Um, is the power part okay? Was the one? Did you get two drastically different power curves? Oh, I can't prove it. Oh. Yes, okay. But yeah, a little bit different.
Yeah.
Okay, good. That's right. All right.
Okay. What's that?
So the rejection rule, idea of rejection is something I think this class is not very good. Even so what you do, just you want the probability of rejecting the null to when the null is true to be because what
That I always read the orders.
because probability of rejecting null not true. What is equal to the so but you know when you reject the null uh, y bar minus x. What should this thing x for this probability? Because this one has the key distribution that always. So we want this to find out how large should be that after t crosses that I will choose the reject. And what is probability? What's up with this probability of y bar, sorry, yeah, y bar or minus k and what is the downside? So the downside is that what is finished, right? Because one, so what makes this thing that keeps is when now is true, then this ends. So we want this probability of something exceeding a certain amount to be. And what number is that? That you write it down. What number should it be so that this t distributed thing happens with a probability? Mm, yes, yes, yes. Good. In that case, under the law, this is a key, and you know that for distributed, the probability of it exceeding this is number one. And therefore, when you now turn this into a rule, in other words, when this, I want this to happen to the probability of one, basically. But this becomes a rule, and usually people don't write rules this way, they write it as y bar, and then something like that. Is that okay? Right? So you differentiate between the p value, which is what did I see, and versus what should this be so that I reject the law with certain probability.
Okay. So how do we know?
Okay, here I should done at this stage already. Now just you can even get rid of the probability of this. Turn this into a rule for someone. Big y bar,
One.
something that's right. Turn it to a simple rule, kind of like what I gave you. It's a distribution also. So now we know that only device by polymer is that. Okay, and what is the significance of this rule? This rule will give you text that has the specified. I mean, you know what? Because you go backward, this will lead to this will lead to this problem. That's why we say this rule has a significance level of points.
That's all I have to do.
Oh yeah. So this the rule is reject now when the region is the rejection region is good. So you should have found for your answer for A and B, you put in the value of S, right? So actually, that should you can actually not put mm, like not put when you're developing food, you think this is right? I don't know. It's not wrong to put the value of S in, but that becomes specific to exactly this problem. Right? If you saw a different value of S, within the rule, it's still JSON. You can write it in terms of the model of create. Right? So now, back to error method. Next, that you can't actually do it involves.
Is this the graph?
Yeah.
Okay, so like,
Oh, I know why you say that. I think because you, when you look at your y-axis, you look at your what, your y-axis.
oh,
Yeah, so it starts from 45. Maybe what you can do. trying to make it show from zero. And you can do that by putting a wire in to C0.
Okay.
Oh, easy event makes the ground. So, okay. So see, you have an expression involving X bar,
Yes.
S, and then involving the unfortunately it's not the bar.
Yeah, my bad.
No, that happens to me too. I hate that. So sometimes I write it as a cursive S. So this expression now is going to involve okay, that's fine. So this is something involving one. So right? So so this same just like this. Basically, this is 19 parts. And then the type 2 error or type 2 error which set so set points the opposite of this, right? That's why you have to listen to context. You accept the know when opposite of this. So this to know and as yes plus so you have expression involving this is the one yes, I see right now the expression called okay, I think we're all on the same page here in terms of doing this problem. This worksheet. Yes. Okay. So let me explain. Why did I not ask you to find that probability? Because you can't. Right? What's the difference? Why was it? Can anyone tell me why was it previously you could always evaluate the type 2 error probability? I mean, it's complicated, but you could do it. Why? Because those were all based off standard normal. If you look carefully at the expression that I have asked you to write, you should have found that you have something involving y bar or x bar, depending on what symbol you doesn't matter. Some meaning that is the standard deviation and some number. But do you realize you can't standardize this to find a probability? You know why? Do you know what sigma is? No. To standardize something, you need sigma. So you might say, well, why don't I bring S down and make this into a T distributed random variable? That's not easy as well, because when the truth is mu is not 90, bad things begin to happen. So I just want to express what's actually going on with this problem. Right? See, previously, when you have a simple rule like this, and then you say, okay, when I don't reject, I have something like this. Right? How do you find the probabilities of these kinds of things happen? Well, you standardize. You subtracted the true mean, whatever it was, and you divided by sigma over root. The problem now is your rejection rule has become more complicated. It is an expression involving 19 and something like that, and then something involving an S term. So you might say, well, we know how y bar and s play together. You can write this as y bar minus some true mean, okay? And then you divide by s over root n. The problem is this. This only happens if you know the true value of sigma, which allows this to become a standard normal variable. Because something is t distributed only when it is a ratio of a standard normal over the square root of, this is not required in the problem. I'm just giving you a little bit more insight. This is a very, very much more complicated problem, which is beyond this class. Because y bar, you can only use the fact that this is t if you have something that is standard normal on top. And to standardize something, you need to know what sigma is. But in model 2, sigma is unknown, which means I would have to not only tell you the true value of mean, I would need to say hypothetically, let's say sigma is 2 or something like that. If I gave you sigma and I gave you mu, then you can proceed. Okay, so the point of the story is that you need to know more than just mu if you are going to evaluate power when you have a situation where sigma is coming. You don't just, it's not enough just to know what mu is, you also need to see it as well. Right? It's just that in the previous problems, they were simpler because sigma was a known situation. So everything worked out really easily and you can just standardize it. The trick here is to use a t distribution which involves s, you actually need a standard normal here. And how do you standardize it? You need sigma as well. And this becomes something pretty horrendous. It's going to introduce what's called the non-central t distribution, which is totally not required in this course. But just okay. So there was a little bit more insight into a more realistic problem, I would say. If you went on to grad school, in anything statistical, you might see non-central t, so you put it here first. All right. Let's do another one. This is another practice for power, but now involving sigma. So this will help you to revise uh, what I'm trying to get across for group of 23 is that you can also do power calculations, not just for mean problems, but even for sigma as well. You just need to know the mother or parent distribution. You need to know the source of what is the distribution that you are interested in, right? Again, if you need help, just let me know, right? I will come help.
So we said to still like standardize instead of working.
Right. So in group work 23, you don't standardize the same way, but you need to write it so that you know that the thing has been. So you standardize in the sense of all set that on, and so you have to write it in a form that has the textbooks. That's right. Just why did you do this? Because with this message, focus on get of thing that you want because even though in general it's quite small. So see something, it's not easy. It's something that means it's a bit plastic.
Yeah, I know.
Yeah.
Okay.
All this basically not in general, right? How we work it out so that the whole point is how do you get it any problem? Even distribution of being that you're subject of the problem. That is why he said that no, that's the thing. So how can you massage this to use the fact you need look true you always for how do you I think it's something here along the lines that correct and then you can grateful for. So I suggest maybe thinking myself to square first, then add some other stuff because it gets pretty airy. Yeah. And square. Right. massage. And you see, that's right. You're right. Sure, because now I'm sure that would make this as well going and geographics in this also important. That's right. And you can always see between one and one. And you are what I think I'll move from one side to the point. Let's do the test. So if you did that, basically, uh, to check and is two trying to yeah. So essentially, yeah. So you don't reduce seven. What? Right, right, right. No, I think the very hard to do this. So thinking, that's a, no, I see the way the way you that's the way that kind of so you are thinking this this one-sided text would not make so much sense because we observe one. Can you change the form to sigma and then just flip this flip something. So you would basically reject the norm. Yeah. So you might need to change something. So you basically reject the norm when your S is not more than something, but less than. So you still need a presidential rule. You need to find because it's always does not want 5% on the other side. So, so if you're 5% on the other side, you know what the right side will be. So if you want 5% of the left side, then the right side is 5%. Yeah, so that basically if you choose and even the right significance and it's a real so and now you would reject it out if it's less than that which the surface think that what you makes sense, right? As long as it S is less than this, which makes sense because you know your very test is right? So which means it's I think it's a little bit more straightforward. Reject the norm for S less than 6 point something. Um, so you get the true value of sigma and then write this as for S. So you oh, yeah. What you have to do is bring this up and put it in that the stage is because when you develop a test, see what you see. I'll say, yes, simulating. Basically, when you develop any objection, you are basically trying to write probabilistic statement. Because you need a statistic that know what is for the case of the mean, we know that this is either a standard normal. For the case of S squared, we know that this distribution. That's it. Work this out. Or we do the S squared. We can use the S squared and bring this down. Because basically, our school should always be stated with proofs of someone.
Why we like
Why not? Right? Because why not is this now S is statistic
that like wasn't
to make S subject of the
yeah, so last time.
Oh, just so much thing. This is not the right thing. Draw a picture. This is saying if you don't have to do it, you want the probability statements. But you can us be similar.
Yeah.
That's right. That looks this way. Stage of the decision because the potential errors are only very. I just see that in office. And it's also
And then actually
to the basically check out my tests. Now, adopt that rule.
like the bullying before.
6.4 minutes.
Yeah.
So the probability of the two large until we get the thing on. Yeah. Can you get a range for this probability?
Yeah. Oh.
I definitely want to see if you know how to read the question. So what the value for to get just raise? Yeah, see that. So not a very satisfying answer, I know, but it's very broad, but it's still true. So it's the hopefully that one's for yeah, the 20 so the problem the probability is something between, isn't it? So the type of so high for when that is the truth. Mm. Do you want to use power to get the exact number?
Uh,
Use p pi square. Yes, very good. Oh, okay. Are we able to evaluate to probability? Did you treat it as a unevaluated? Yeah. Yes. Okay. That's true. It will be the probability of zero this when this is true. This is mathematically together, but yes. Oh, it's all all massage this statement to look at what is fast. Just like here. This food is really exclusive. What's the probability of in the concept? Something because you don't know the description as
okay.
but we know the description.
Okay, this no.
Yeah. Yeah. So there's
Yes.
Okay.
Like not like an apple.
That's right. So yes, so square roots, square roots, and so the probability statement is carried. So it's still the probability of, right? You can still write it as equal to. You are still trying to get it over. What I'm trying to get across to class is other massaging is actually easier. But look at this. What's it? Yes,
Actually,
because that is to them, what is my analogous to what you propose. No sigma, no zero,
Like I know I said that.
and you can hit this concept. That's all it's doing. Right? Because now you know the distribution of this one. We have a bit of time more. So we are going to shift gears. Are we quite okay with the concepts of type 2 and type 1 error and standardizing? I put it in quotes because how you standardize something depends on the statistic at hand. If the statistic you have is a mean, you standardize, and if you know sigma, you standardize it by doing that familiar y bar minus mu zero over sigma over root, and that turns it into a standard norm. If your statistic is S, which S alone, we don't know how it behaves, but we do know how n minus 1 S squared over sigma squared behaves, turn it into that. Basically, massage. If there's one word you must leave as statistics class is massage, massage, massage. Always massage things until it gives you a form that you recognize and know how it behaves, probabilistic. Just saying S alone is mathematically true, but unfortunately unevaluable. No one knows how to derive the distribution of S alone. Horrible. But we do know how n minus 1 S squared over sigma squared is. So massage. All right. Okay. I will leave you with one group work, which I think you can do in the time that remains. If not, you can take it back. We're going to shift gears now to something else. So this is going to be totally different. Do you know how to do this kind of problem? Do you remember? All right. So I'm giving you a PDF. You know, not normal, not chi-square. It's a simple one. It's theta y theta y. That's a PDF. I know what PDF is. Find the value of t so that you can find the lower 5% on top. What am I saying?
Oh my gosh.
Yes, okay. So draw a picture. Always, always, always draw a picture. Okay. This PDF has a support between 1 and 4. Yes. So draw this. All right. Pick a value of theta that's exciting, right? Don't pick one that's, let's say theta is 3. Just to get an overall view of what the shape looks like, can you plot 3y squared? If you're a math major, no problem, right? So draw the density for when theta is 3. Just do a quick sketch so you actually know what kind of density it is. It's only stuck between 0 and 1. And you can draw it for theta equals to 3. You should see a curve like this. Do you agree? I think you should get that. Now, do you understand the question? Find the value of t, and this will be in terms of theta, so that the probability of y less than t is 5%. Draw a picture. You've been dealing with tables all day. What I want is this. Find what this is, so that this area is how much? Yes. The reason when you use tables is easy is because all these quantiles have been found for you for specific areas under the curve. Now I'm asking you for this strange PDF to find this manually now. Anyone have any ideas how to proceed? How do you find T? So, okay, yes, Anya, what did you say? You have to integrate what? You do integrate, that's right. Yes. The PDF, can you do that now? And I think you can do this before time's up. Put the PDF in terms of theta. And set this equal to what? Let's see the SET. You set this to be, yes. So all you need to do is work on this. Your T will be a function of theta because you don't know the parameter. You don't know what to do. Actually, you can give yourself a pat on the back. If you can actually understand this, that's actually good. Because there's a lot going on, many moving parts. You know probability is area under theta. You know that from 365. And you want to find what this, the technical word for this is the 5% quantile. Percentile, sorry, quantile is 25%. 5%, the 5%, the 5%, the 5% now, the 5%. All right. And if you're done with that, you can go, right?